2.4, multiplying matrices. Example 1 says calculate 4 times A. This is the easiest type of multiplication, scalar multiplication. We're just multiplying 4 times that matrix. You can think of it as distributive property if you want, but we're just going to multiply 4 times each of the elements. 4 times negative 2 is negative 8. And 4 times 5 is 20. And 4 times 0 is 0. And 4 times 1 is 4. That's it. Now, I want you to be really careful because the rest of the lesson is not that easy. That's a pretty easy problem. Multiply a number by a matrix, that's good. But when you multiply a matrix times a matrix, there's a lot more to it. So don't try to do that if that's not what is called for. Now, I have a typo here, so let's make sure we fix this typo. The importance of size when multiplying two matrices. The number of, I should have said columns here, of the first matrix must equal the number of rows of the second matrix. And 2, the size of the result is equal to the number of rows of the first matrix by the number of columns of the second matrix. Most normal people read that one time and get confused and think that they don't understand it, okay? But what you've got to do is probably read it more than once. What I will do is I'll read it once or twice or whatever, but then I'll start trying to think about numbers. If you'll put numbers in there instead of the words, you'll understand this a lot better, okay? So example 2 says, if it's possible to multiply the matrices, determine the size of each product. Okay, so let's look at this. All right. So the number of columns of the first matrix must equal the number of rows of the second matrix. Okay, so let's look at the size, all right? Look at the size. What's the size of that first matrix there? 2 by 3, thank you. And you're multiplying it by a 3 by 1. Remember yesterday when we talked about rows before co's, there are 3 rows and 1 column in that matrix. Okay, so if you look back in that gray box, bullet point number 1 says the number of columns of the first matrix, so 1, 2, 3 columns, this number. My marker's not working. Must equal the number of rows of the second one. So row, 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 right there, 3 rows. Notice these two numbers are equal. That's what you need to look for. When those two numbers are equal, that's what that's talking about, okay? The number of columns of the first must equal the number of rows of the second. All right, great. Bullet point 2 says the size of the result is equal to the number of rows, or this number, of the first matrix by the number of columns, or this number, okay? So what happens is when those two inside numbers are equal, you just take the outside numbers and the result is 2 by 1. So I'm not going to look at all those words. I'm not going to remember those big, long definitions. I'm just going to say, okay, I've got a 2 by 3 times the 3 by 2. I'm going to look at the sizes. And I look at these inner dimensions right here, and they must be equal. If they are equal, then these outer dimensions represent the size. That result is going to be a 2 by 2. We look at the last one, a 2 by 3 times a 2 by 3. And this one tricks a lot of students. A lot of students that don't quite know what they're doing will say, oh, well, the result's just going to be a 2 by 3. Because when we added matrices yesterday, we knew that the matrices had to be the same size. But this isn't going to work. If you look back in the gray box, these two things are supposed to be equal, but they're not. If those two numbers are not equal, then this multiplication is not possible. So we've got steps for how to multiply. Number one, determine the size of the result. Okay, so that's the same thing that we just did. 2, build a blank skeleton matrix. 3, okay, let's just go ahead and get started. All right. So this is a 2 by 3 times a 3 by 1. So step 1 says determine the size of the result. These two things are equal, so we know that the result is going to be a 2 by 1. Step 2 says build a blank skeleton matrix of the result. Here's where some students are going to resist, okay? Students that don't like showing their work are probably going to try not to do this, but I think multiplying matrices potentially gets really confusing. So the whole reason for building a skeleton matrix, I'm just building kind of like an outline of what's going to look like, is to keep myself organized so my eyes don't get crossed and I don't miss something that I shouldn't have missed. So if I know this is a 2 by 1, then all I mean by building a skeleton is build it, and then let's just put like blank and a blank to show that it's going to be 2 rows by 1 column. Okay, so I make it kind of big. I put a blank in there to represent where my numbers are going to go, but that's going to be a 2. That's going to be a 2 by 1 matrix. Okay, so then you might not want to do number 3, but it might help. Number each row of the first matrix, 1, 2, and each column of the second matrix, 1. What you're going to do is you're going to multiply each row by each column, okay? So you're going to do what we did before, zip up the numbers, basically. What I used to do is I used to take a pencil and just kind of lightly draw a line through the top row and then lightly draw a line through the first column. And it doesn't really do much other than just kind of train my eyes to zip correctly, okay? I am going to multiply each of those elements in the first row by each of those elements in that first column, okay? So -5 times -2 is 10. And 3 times 1 is 3. And -5 times -6 is 30. Now I move down to my next row. 4 times -2 is -8. -5 times 1 is -5. And -2 times -6 is +12. After that, I'm just going to clean up my numbers. 10 plus 3 plus 30 is 43. -8 plus -5 plus 12 is -1. That's my answer. I have a 2 by 1 matrix, 43, and -1. Okay? So that's it. That's how you multiply. You just do that over and over again, and you're going to run into problems when your eyes are going to go cross and you're going to get confused. Okay? So let's look at the next one. Okay? Talk about the size. We've got a 2 by 3 times a 3 by 2, which is going to result in a 2 by 2. So I'm going to build out the skeleton. A 2 by 2. Hopefully I have enough room there. You might not. Okay, there's my 2 by 2. And I'm going to multiply each of these 2 rows by each of these 2 columns. Okay, remember rows before co's, right? We're going to multiply a row times a column. So again, I thought it really helped to just lightly draw a little line through the first row and the first column. It helped me to stay organized. So let's do the first row times the first column. 2 times 4 is 8 plus -2 times -4 is 8, and 2 times -2 is -4. Okay. So what that means is my first element is going to be 16 minus 4 is 12. Now I'm going to do first row times second column. First row times second column, 2 times negative 4 is negative 8. And negative 2 times negative 6 is 12. And 2 times 6 is plus 12. That's going to be 4 plus 12 is 16. And then I do the bottom row. Second row, first column. Okay, second row right here. 1 times 4 is 4, and 6 times negative 4 is minus 24, and 6 times negative 2 is minus 12. That's going to be negative 20 minus 12, negative 32. Second row, second column. 1 times negative 4 is negative 4. 6 times negative 6 is negative 36. 6 times 6 is positive 36. 36 is canceled. I get negative 4. And there you have it. There's my 2 by 2 matrix. Okay. Number 4. Suppose matrix A is 2 by 2 and matrix B is 2 by 4. Can the products AB and BA be calculated? So all they're asking you to do is look at AB. AB is a 2 by 2 and B is a 2 by 4. Is that possible? Okay, well, yeah, that's possible. When those two match, it's possible. Your result is just going to be the outside numbers, 2 by 4. But then you look at BA. BA is 2 by 4. And matrix B is 2 by 4. Matrix A is 2 by 2. When those are not equal, this is not possible. So what this example is supposed to show you is supposed to show you something really important about math. Think back to algebra class, and when you've had a property that says 3 times 4 is the same thing as 4 times 3, right? That property has always held true. Always, 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 that's held true, that 3 times 4 is the same thing as 4 times 3, okay? That kind of goes out the window when we're talking about matrices. We cannot say that A times B is equal to B times A. That doesn't work. That property does not hold true for matrices, and you can see it in that example right there. So number 5 says, do you think it would be easier to find AB or BA? Okay, so think about that for a second. AB or BA? Well, it might be the size that determines that. So if I did A times B, that would be a 3 by 2 times a 2 by 3, resulting in a 3 by 3 matrix. But if I did BA, that's going to be a 2 by 3 times A is a 3 by 2 is a 2 by 2. So do you think it would be easier to find AB or BA? I think probably this one would be easier. It's just a smaller matrix, okay? It's a smaller matrix. So I mean, you could argue with me and you might have a point. It's kind of an opinion question. But to me, I think it would be easier for BA. Then find it. Okay, so they want me to find BA. Now, trust me on this. It is hard to do BA when the matrices are written backwards like this, okay? Because your mind has already been programmed to do rows first. So you're already looking at rows and then columns. I would highly recommend you just to rewrite it in the right order. I know some of you don't want to rewrite it, but trust me, it is really hard to keep these numbers right in your mind. So do yourselves a favor and rewrite it in the correct order so you can see the row times the column. So again, I used to always kind of draw like a line or a highlight or something just to get my eyes going in the right direction. All right, that first row times that first column. We know it's going to be a 2 by 2. We already said that. So my skeleton matrix two by 2. We do that first row times the first column. 1 times 1 is 1. 0 times 7 is 0. -1 times -2 is +2. First row, second column. That's this column, right? 1 times -3 is -3. 0 times 2 is 0. -1 times 5 is -5. And then second row, first column. 3 times 1 is 3. 1 times 7 is 7. 4 times -2 is -8. Second row, second column. 3 times -3 is -9. 3 times 2 is 6. Ooh, I messed that up. 3 times -3 is -9. 1 times 2 is 2. And 4 times 5 is 20. So then last step is just clean up. 1 plus 0 plus 2 is 3. -3 and -5 is -8. 3 and 7 makes 10. Minus 8 is 2. -9 plus 2 plus 20, that's 13.